Hi everyone, in this video we're going to be discussing the differences between Pythagorean theorem and trigonometry. Let's recall the Pythagorean theorem. A squared plus b squared equals c squared, and c is the hypotenuse, which is the longest side across from the 90-degree angle. You can only use Pythagorean theorem when it's a right triangle and when given two sides in order to find the third. Let's look at a few examples. Here we have a right triangle and the legs are 64 and 48. I'm looking to solve for the hypotenuse, which is across from the 90-degree angle, which is c. So a squared plus b squared equals c squared. 64 squared plus 48 squared is equal to c squared. Put this all in your calculator, you get 6,400. Take the square root and you end up getting 80. So 80 is our hypotenuse. In this next example, you have a right triangle and you're given two sides, 372 miles and 620 miles. The 620 miles is our c, our hypotenuse, because it's across from the 90-degree angle. Substitute these values into our Pythagorean theorem, and you end up getting x is equal to 496 miles. Notice again, you can only use Pythagorean theorem if you're given two sides of the right triangle and you're trying to find the third side. Next, we have trigonometry. You can only use trig when you're given a right triangle. You can use if given one side and one angle, and you can also use it if you're given two sides and you need to find the angle. Let's look at an example. So for example, if we have to solve sine of 36 degrees is equal to y over 47, don't forget to put it over 1 and cross multiply. Y is equal to 47 times sine of 36. Type that into the calculator and make sure you're in degree mode, and you end up getting 27.6. For our other example, we have tan of 55 is equal to 425 divided by x. Notice that x is the variable in the denominator. Remember, we switch positions and we have 425 divided by tan of 55. Put that in our calculator, make sure you're in degree mode, and you get 297.6. Another example we have is tan of theta is equal to 30 over 19. We want to solve for theta, which is the angle. So don't forget, when you're trying to solve for the angle, you put in second tan of 30 divided by 19, and you end up getting 57.7 degrees. If you have sine of theta is equal to 10 over 38, again, you're looking for theta, which is the angle. So you have to put in second sine in your calculator, 10 divided by 38, and you get 15.3 degrees. Next, for these questions, we're going to use trigonometry. So don't forget to always write SohCahToa. So let's look at the first problem. 30 is my central angle. The 14 is my adjacent because it touches the angle. And h is my opposite. Notice I have to use trig here because I'm looking for one of the sides. I have a side and an angle. So if I have OA, I'm going to use TOA, which is tangent. So tan of 30 is equal to the opposite, which is h, all over 14. Put this over 1 and cross multiply. H is equal to 14 times tan of 30. Let's put this in our calculator. So we're going to do 14 times tan of 30. And we get 8.082, so we're going to round that to the nearest tenth, so 8.1. Next, let's look at this example. 27 is my central angle. The z is my hypotenuse because it's across from my 90-degree angle, and the 55 is my adjacent. Notice I have AH, which means I'm going to use cosine. Cosine of 27 is equal to adjacent, which is 55, over my hypotenuse, which is z. Notice that the variable is in the denominator, so we're going to switch positions. So z is equal to 55 divided by cosine of 27. Let's put that in our calculator. 55 divided by the cosine of 27. 61.727, so that's going to be 61.7 rounded to the nearest tenth. Z is equal to 61.7. So remember, you can use trig when you're given one side and an angle, and you're looking for that missing side.